Hi, welcome everyone. In today's tutorial, I would like to show you a very simple circuit to connect to a pickit2 to a microcontroller, which is a MPLAB microcontroller pick18F4550. So if you go to the schematic diagram of the pickit2, the pin diagram basically, what you will see is like this. So in the pickit2 programming pin, which they also call as header, the first one is a VPP and MCLR, and number 2 is a VDD, number 3 is VSS, number 3 is in-circuit serial programming the data port, and the fifth one is in-circuit serial programming clock. And the number 6 is an auxiliary, which we can ignore or we can leave it open. So going back to the PIC 4550, I'm using a 40 pin PDIP in which it says like the number 1 is a MCLR VPP. So we connect the number 1 VPP, number 1 port of pickit2 to the VPP, and then we have 11, 12, and 32 and 31 for connection for VDD and VSSS. So we will do the same, and in case of the serial programming, we will connect to the data, we will connect to 40, and the clock we are connecting to 39. Okay, now let's go here and try to see. I have a, as you can see on the screen, I have a pickit2 programmer which is connected to pickit18F 4550. And now the circuit is very simple. It's a very basic and simple circuit, so that everyone can be aware of. So the number 1, this starts with number 1, as you can see in the arrow. The number 1 is connected to the number 1 of VPP, that's the VPP1. Number 2, the brown one, is actually going here, and then by course of time it's going to here and then connecting to the number 11. Similarly for the VSS, we are connecting to the number 12. We are not connecting to the other end, we are connecting to the same end. So okay, so to make things again repeat, this is the VPP which is connected to number 1, VDD 11, and the VSS to number 12. On the other end, I have 2, 4, and 5. The 4 goes to number 40, which is for the data, and for number 5 we are connecting it to the clock. So this is the number 5, which in turn goes to number 39, which is a clock. So if we, let's take a look. This is the view of that. And then when we go into the programmer, I hope it's visible to everyone. Okay. And then what we do is that we go to tools and we will check the communication. So what it does is that it's showing busy. Okay, it's done already. Anyway, so we see that the PIC device found, the device is PIC 14.4550. Then we will configure that VDD, the voltage. So you can, the end is 5 voltage maximum, and if you drop down you can go up to 2.5. It don't allow you to go beyond 2.5, as you may be knowing that. We are keeping the MCLR, the VPP port open. We don't want to use that as IO port. We want to do a VDD as a IO port. So, and then once we connect that, we have all the program memory is open, as you can see in FFFF. So if you go to file, import file, I have a programmer. I have developed a program for ADC conversion. So when I import it, it shows me the hexadecimal file and the FFA, so till this point I have some memory, it occupies some memory, but after that it's all blank. Now when I try to write it, it gives me a warning. So it says that it requires at least 3 volts, so I increase it to 3.5 volts to a server side and then try to write it again. It's trying to write, so programming successful, that means it has written successfully. So that's all about it. Like I wanted to demonstrate the basic circuit to in conjunction with PIC programmer, pickit2, and the PIC microcontroller. So that's all about this tutorial, and we'll see you next time. Thanks, bye.